Okay, so here's your chance to review circle trig. What if I said, what is the sine of 7 pi over 6? All right, I'm going to help you guys in a second. I just want to get them started on something. Here's where 1 pi over 6 is. Here's where 6 pi over 6 is. That's where 7 pi over 6 is. So if I said sine of 7 pi over 6, that would be like this. Here's the triangle. Oh yeah, that's right. I know this one. This is a 30, so this is a 1, 2, square root of 3. Oops, what's the most common mistake in circle trig? Negative. So that's negative and that's negative. And sine of it would be opposite over hypotenuse. And this is opposite. And this is the hypotenuse, and I made it negative. Do you ever make the hypotenuse negative? No, that shouldn't be negative. What should be negative? The 1 is negative, yep. And this one? The root 3 should also be negative. Okay, so back to sine is opposite over hypotenuse. Final answer, negative 1/2. There's a 2-second review. All right, so here is a problem. See if you can do this one. It's kind of like that. What is the cosine of 5 pi over 6? I always recommend drawing a picture. Picture's worth 1,000 words. And then try to figure out that answer. I'll pause for a second while you give that a try. Okay, let's see if you did it right. That's where 5 pi over 6 is. And then I draw a triangle around it. So if that's a 30, okay, hey, I don't mind if you're like whispering to the kid next to you, but don't be loud enough so you're messing my video up. All right, so I have opposite, or wait a minute, because cosine is adjacent over hypotenuse. I better label these sides. That's a 1, that's a 2, that's a square root of 3, and this is negative right here. Only that one's negative. Did you guys label it right? Okay, good. Then what is the cosine of that? Cosine is adjacent over hypotenuse. You should have said negative root 3 over 2. Raise your hand if you had that one right. Okay, awesome. Now let's do a little bit of review of what are those other functions. So, would you use the same exact triangle and figure out what in the world is the secant of 5 pi over 6? Don't say it. Figure it out. Remember, they're the flippin' sisters. There's secant and cosecant, and there's cotangent. Those are the 3 new ones. They all have a sister function that you know. And my advice on these was to say, Mr. Server, I'm not going to do secant. I'm going to do the other function and then flip it. So don't do secant of 5 pi over 6. Do the sister function of it and then flip it. Okay, so you should have said to yourself, I don't want to do secant. I want to do cosine. Cosine of 5 pi over 6 would have been, oh, I just did that one. Negative root 3 over 2. So is that the answer? No. You flip it, so it's 2 over negative square root of 3. Flip this part over. And the negative, doesn't really matter where the negative is. I can put it on the top if you want, or you can put it on the bottom. Doesn't matter, because remember, negatives don't matter whether they're the top, middle, or the bottom. All right, so there's a secant question. Let's do one more like that. Cotangent of 45 degrees. I'll pause for a second while you give that a shot. Okay. Cotangent, I would say I refuse. Instead, I will do tangent of 45, and then I will flip it. I'm going to put a little star here just to remind myself. It's not really tangent of 45. I'm going to take that and then flip it. So here's 45, and I've got a nice little 1, 1 square root of 2 triangle going there, which is tangent is TOA, opposite over adjacent. So it's a 1 over a 1, and when I flip it, I get 1 over 1. So the answer is still 1. Raise your hand if you had an answer of 1. Okay, awesome. All right, so here's where they get harder. What if I said cotangent of some angle I don't know is 2? And I don't even want the final answer for that. I don't know. I don't even care what that angle is. What I want to know is what is sine of that angle. Whoa, mind blown. One more clue. I'm going to tell you that we are in quadrant 3. always draw a triangle picture and label it with all the sides and as many angles as you can get. If you don't know the angles, but you only know the sides, a lot of times it'll still work. All right, I'm going to pause for a second. Let's try that. Okay, I'm hearing rumblings that I may have set up an impossible problem. Here's how I will attack it, and we'll see if I'm right or they're right. I could definitely be wrong. A lot of things going on right now with the VR and everything. All right, so here we go. First of all, I would say I'm not doing cotangent. I'm going to do tangent. Tangent of same angle equals, but if you flip to the other function, you got to flip this, like that. Okay, now is that possible? Yes. Is it a normal situation? No, but it's possible. Now I'm in quadrant 3. Ooh, that might be a problem, but I'm going to check. All students take calc. Is tangent positive in the third quadrant? Let's look. Tangent, that the t there does mean tangent is positive there. So I can draw a positive one for that. And then tangent, TOA, opposite, adjacent. I'll send another. Oh, I got another one out there already. Okay, good. So then this side must be square root of, let me think, square root of 5. How many of you guys figured out that last side? If you got duped into thinking this is the 1, 2 square root of 3 triangle, you wouldn't be alone. All right. So then, if this is 1 and this is 2, that has to be the square root of 1 squared plus 2 squared. Okay, and then what's the most common mistake in circle trig? Negative, so it's really easy to forget that that's negative and that's negative. Will it matter? Yes, it will, because at the end I wanted the sine. Sine is opposite over hypotenuse, and here's theta. So sine of theta is opposite over hypotenuse, so it's negative 1 over root 5. That one was doable. Any questions about that one? Okay, so what's next? Oh, there's so many things, but I want to talk to you about sinusoidals. Do you remember those deals that they go up and down and up and down? And we were able to write equations for them. We even had a lab on that. Are you listening, actually? Okay, good. So this is going to be our, let's say this is the x and the y-axis is going like this. Let's say that that's at pi over 6. And this one's at 5 pi over 6. And then let's say this is at 8. And let's say this is at 2. Now you know everything you need. You need a low point and a high point. Can you write me an equation for that? We did it in the lab. All right, I'm going to pause for a second. Okay, in case that was not enough direction, here, let me give you a little hint. The amplitude depends on this line that runs down the middle. Do you remember me saying it was called the midline? I called it center line for a while until I looked it up, and it's actually called the midline. And that goes from the midline, which would be at average of 8 and 2, which would be 5. That goes from 5 to 8, so that makes this 3. Do you remember we always use cosine? 3 cosine, and then why do we always use cosine? Because it's easy to tell how far that's been shifted. That should be here. That peak should be there, but it's not because it's been shifted over. How far has it been shifted over? It's been shifted over that far. It's the x value of the first peak. So that right there goes here, pi over 6. Has this one been shifted up? Oh, yes, it has. This dotted line should be right at 0, but it's not. It's at 5, so that's plus 5. And it looks like we're ready for our next person. Is there another one coming? Come on out. All right. So then this part right here, that's the b. Let's try to figure out what the b term is. There was a little separate little mini equation you had to know. Period equals, can you finish that one? 2 pi over b. Does that ring a bell? Period equals 2 pi over b. So if my b is given, nope, I don't have the b. If my period is given, oh, yes it is, because I know from here to here is 5 pi over 6 minus 1 pi over 6, which makes 4 pi over 6. If the period is 4 pi over 6, now I can solve for b. It's a little bit icky, but it actually comes out to just a simple fraction when you're done simplifying it. I'm going to multiply both sides by b. And now I have b times 4 pi over 6. Did you find her? Could you bring this to the math office and ask if anybody knows where Mrs. Eichler is? Thank you very much. Yeah. The next one is 2 pi over b. And now I'm going to divide both sides by 4 pi over 6. So it's 2 pi over b divided by... Wait a minute. I forgot to cancel the b's. You're right. That b's gone. That b's gone. 2 pi over 4 pi over 6. And that means b equals flip and multiply 2 pi over 1 times flip and multiply 6 over 4 pi. Pi's cancel. 12 over 4, which is, unless I mess something up, I think that's right. Did I see any mistake in it? All right. That's the basic process where you are taking this formula, solving it down. Apparently b equaled 3. Okay, that is called a sinusoidal. Yes? Oh, yes, that's right. That's why I felt like 3 was wrong. This was 4 pi over 6. That's how long this was. But you got me. 4 pi over 6 isn't the whole period. That's half the period. So I should make it 8 pi over 6. Question? It was from here to here, and that was 4 pi over 6, but that's not a whole period. So I got to go, that's a 5. Never mind. Okay, so anyway, all right, I got to pause for a second here. Oh, okay, I apologize for the confusion on whether that was a 5 or not, and now I hope you see that this is 4 pi over 6, and then a kid noticed that I hadn't doubled it, because remember, the whole period is double that. So I should have put 8 pi over 6 was the period. So I'm going to put in a nice bright green 8 pi over 6. And then I'm going to flip and multiply by that. So this is 8 pi over 6. And this is an 8 pi over 6. And then this is flipped and multiplied. This is an 8 pi down here. And so then the final answer is 6 times 2 is 12 over 8. So now the answer is 12 over 8, but I got to reduce it. So sorry about that. 3 over, let me think, the 4's cancel. 3 over 2, I think. Double checking that. I should just take the time and do it. 3 times 4 over 2 times 4 cancels. Yep, 3 over 2. So the B term was 3 over 2. There we go. Whew. Okay, all good things to know. Now, are you noticing any overlap with the packet? Because sometimes there is. Sometimes I've just given you help on a problem that's on your take-home also. Okay, so what else do you need to know? Well, I do want to open it up to questions in general. Is there a type of math that you know we learned this semester that you want to ask a question about? I don't want to do a ton of time for questions, but give me a suggestion, and I'll hear your suggestion too. Okay. Cis form and demov is what you're probably thinking of. All right, I'll give you a 2-second reminder about that. So cis form. If I said 2 cis pi over 6, I hope you would know what that means. All right, so if you don't, in case you don't know that, I'm going to show you a picture of it. Big surprise there. I really like to show you where it is. So here's where pi over 6 is, and 2 means the radius must be 2. So there, and this must be 30 degrees, and then I could know a lot of things, like rectangular form for that is how far this is in x and how far this is in y. And we could figure out a lot of things from this. But if the question was specifically about exponents, let's say I wanted to square this. If I was going to square this, then demov comes into play. And demov is about the move of the exponent. So I take these squareds and I put one here, and I put one there. And then if this is one of those problems where I was finding like the 3/3 roots, then I'd put in a plus 2 pi k, and I'd put a 2, that last 2 there. I'd bring it down and put it in front of the plus 2 pi k thing. All right, so there's a quick 2-second reminder about cis. There's so many things to know. What was your suggestion, sir? All right. Do you want more about cis? Is there anything else? Do you remember how to divide things that are in cis form? Like, let's say it was this, except divided by 4 cis 5 pi over 6. Do you remember if you divide those? Then you take this divided by this, which would be 1/2, and that minus that, which would be negative, so cis, and pi over 6 minus 5 pi over 6 is negative 4 pi over 6. What's the rule on these? They can't go past pi. So if you ever get an answer that's like 7 pi over 6, bigger than pi, then you got to go the other way. Okay, so there's a few minutes on cis. Any other topics you guys would like to bring up? Otherwise, I'll just keep going through things I know are important. Get me. All right. Thank you. Muchas gracias. Okay. Do you remember the parametrics unit? Parametrics are a big deal. Had a whole chapter on this. We ought to review it for a minute. Do you remember what that would create? Yes? A circle with a radius of 2. Very good. Do you remember that parametric could be rewritten as just a Cartesian, but we didn't used to call them that back then. We used to call them rectangular. Do you remember how you can get the t out of there? How about this? Just one, we'll do baby steps. We would, okay, pausing for a second. Okay, so let's say I had the TXY chart. Why is that handy? Because it gives you points, and it also helps you with the range. And remember how these always have a limit? Like, oh, by the way, t has to be between 0 and 1. Does that ring a bell? Remember those? And this kind has a t limit, but a rectangular would have an x limit. So would you just take a second and put in t equals 0 and t equals 1 and figure out what you get? Pause for a second. Okay. So when I put in 0, t equals 0, I put a 0 here and a 0 here, 12-minute warning. And I have 0, and I have 2. And then I put in a 1. I put in a 1 here and here, and I get 2 and then 5. Why is this helpful? Well, first of all, if I was going to graph it, if I get enough of those points, I can graph it. Secondly, if I want to find the x domain, there it is. Instead of from 0 to 1, now it's from 0 to 2. So why don't you try to figure out what the actual equation is if you change this from parametric into the other form. What would the equation be? Hint, solve them both for t, and then try to take it from there. Okay, back with you. So, I hope you solved this for t by dividing both of them by 2. And I hope you solved this one for t by subtracting 2 first, and then dividing by 3. So now, I got my 2t equations. I'll copy them to make it cleaner. This one was t equals x over 2. This one was t equals y minus 2 over 3. And now I set them equal to each other. X over 2 equals y minus 2 over 3. You're done. Resist the urge to solve it for something. You don't have to. Unless they tell you to. Okay, that's how you take something that was in parametric and make it into rectangular. There's so many things. I can't cover them all. So, I think for today, it's enough. And I'll cover more. And you guys keep working on your packet. Tomorrow, we'll continue with more review questions. I'll pause for now while you guys, actually, I think that's the end of the video for the review for today. We'll get some more people through the VR, and the VR will be running again tomorrow if you haven't had a chance to see it today.